Welcome to ScienceCover.com. Today we're going to look at electrical power. We'll look at how to use the power equation. Power is voltage times current, and then how to rearrange this. First, pause the video and complete the Do Now task. Let's check our answers. What color is the live cable? It's brown. What color is the neutral cable? Blue. What color is the earth cable? It should be green and yellow stripes. How much voltage enters the home through the live cable? It's 230 volts. Number 5, what is an alternating current? It's a current that changes direction. How is an alternating current produced? You have a rotating magnet that's going past a coil of wire. What does DC stand for? That will be a direct current. Describe how electrons behave in a direct current. Well, they all move the same direction in a continuous flow. Name a source of power with a DC current. That would be a cell or a battery. Number 10, what is the job of a fuse? It burns when a high current flows through it, so it prevents high currents, overheating, and fires. Look at the power equation. Power is voltage times current. We've come across power previously when we've done power is energy divided by time. So we know that power is the amount of energy used per second. And in electrical circuits, we can also calculate the power by multiplying the current in amps by the voltage in volts. So we've got the equation power in watts is current in amps multiplied by voltage in volts. Let's look at an example of how to use the equation. A battery outputs 5 amps from a 2.5 volt potential difference. How much energy leaves the battery each second? Well, the energy per second is the power. And the power can be calculated with current times by voltage. So my current is 5 amps and my voltage is 2.5 volts. 5 times 2.5 gives me 12.5. So my power must be 12.5 watts. Here's another example. A copper wire has a potential difference of 15 volts applied to it and a current of 7 amps begins to flow. What power is being used on the wire? Well, again, we can use the current multiplied by the voltage. The current this time is 7 amps and the voltage we're given is 15 volts. If we multiply 7 by 15, we get 105. So the power must be 105 watts. Now pause the video and complete task 1. Let's check our answers. The power in watts is equal to the current in amps multiplied by the voltage in volts. Question 2, we have a 1.2 volt cell and it creates 0.5 amps of current. How much energy is lost per second? So we're after the power, which is the voltage multiplied by the current. So that's 1.2 times 0.5, which equals 0.6 watts. An automatron is powered by 4.5 volts potential difference. If 6 amps of current is created, how much energy does the automatron use per second? So power is current times voltage. So this time we've got 6 amps times by 4.5 volts, which gives us 27 watts. A car battery produces a voltage of 12 volts. If 4 amps of current flows through the car electrics, how much energy is the car battery losing every second? So again, we want the power, so it's the current times the voltage. So that's 4 amps times by 12 volts, which is 48 watts. Calculate the power used by each of the following. So the fridge freezer was using 345 watts, the kettle was using 2990 watts, the TV box was using 92 watts, and the hairdryer was using 2300 watts. Now let's look how we can rearrange the equation. We can place power, current and voltage into an equation triangle, with power on the top of the triangle and current and voltage on the bottom. Now if I want to work out the power, I can cover up the power and it leaves me I times V, current times voltage. If I want to find out the current, then I cover up the current and it leaves me P divided by V, so that's the power divided by the voltage. And if I want to find the voltage, then I cover up V, that gives me P divided by I, the power divided by the current. Now pause the video and complete task 2. Let's check the answers to task 2. Number 1, complete the equation triangle. We need power on the top, that's P, and then voltage and current on the bottom, V and I. Voltage and current can be placed on either side of the triangle. Use the equation triangle to write out the equation for power, will be voltage times by current. Current will be power divided by voltage, and voltage will be power divided by current. Let's look at an example of how to rearrange the equation. What current flows through an 80-watt light bulb when 240 volts is applied? So here we're after the current, so that's I. We cover up I, and it leaves us P divided by V. So I, the current, must be P, the power, divided by V, the voltage. Next I substitute in my numbers, 80 for P and 240 for V. Use a calculator to do 80 divided by 240, and it tells me that the current is 0.33 amps. Let's look at another example. A current of 5 amps flows through the wire in 1 minute. If a voltage of 0.1 volts is lost as the current passes through, then how much energy is lost by the wire in 1 second? So I want the energy per second, which is the power. To get the power, I've got to times voltage by current. Substitute in the values from the question. So that's 5 amps for current and 0.1 volts for voltage. 5 times 0.1 is 0.5, so the power must be 0.5 watts. Let's look at another example. What is the potential difference lost over a resistor with a power rating of 5 watts if a current of 0.2 amps is flowing? So this time we're after potential difference or voltage. So that leaves us power divided by current. So we can do V is P divided by I. Power is 5 watts, current is 0.25. So 5 divided by 0.25 gives me 20. So the voltage must be 20 volts. Now pause the video and complete task 3. Let's check our answers to task 3. Question 1, we have a lightning strike which jumps from the clouds to the ground. It's got 300 million volts and a 30,000 amp current. So the power is the current times the voltage, so that's 30,000 times by 300 million, which gives you 9,000 million watts, or 9 billion watts. A lightsaber has a power rating of 250 watts, but is powered by a kyber crystal that creates a 5 amp current. What is the potential difference lost by the light saver? Well, voltage is power divided by current, so that's 250 watts divided by 5 amps, which gives us 50 volts. A spaceship travels to Mars with a 4,000 watt power source. If the ship computer requires a potential difference of 5 volts to function, what is the current flowing through the computer? So we want current, so current is power divided by voltage. The power is 4,000 and the voltage is 5, so 4,000 divided by 5. This gives us 800, and since it's a current, we measure it in amps. A static charge causes a 0.3 amp current to jump between a person and a handrail. What is the potential difference between the handrail and the person if the static bolt moved 2.7 watts of power? Well, the potential difference V is P divided by I, so that is equal to 2.7 volts divided by 0.3 amps, which gives us 9 volts. Question 5. This table shows the data for a kettle, Wi-Fi router, remote control, and car battery. Complete the missing values in the table. So for A, we were looking at 50 volts being the missing value. B, the missing value was 12 volts. C, the missing value was 0.5 amps. And D, the missing value was 13 amps. Which item do you think is A, the kettle? Well, the kettle has got a high current, so it's either going to be B or D. But it's also using 230 volts as we're plugging it into the mains. So D is the kettle. A Wi-Fi router should be using a less current, so that's going to be A. The remote control is powered by batteries, so it's going to have a low voltage, and it's also going to have a low current, so that is going to be C. And a car battery produces a voltage of 12 volts, so that must be B.